Solving quadratic equations by completing the square. So this is another form of solving quadratic equations that we will have in our toolbox. So far we know how to solve by square roots and how to solve by factoring. But as we saw in a previous video, not everything can be factored. So first, let's talk about identifying what we call a perfect square trinomial. So this trinomial means that there are three terms. So 1, 2, 3. And there's a quick way to factor this without having to go through the table and splitting apart b and all of that process before. So if you have something in this format where you have a squared 2 times a and b squared, you can actually factor that very quickly into the value of a plus the value of b all squared. And that's your factored form right here. So how to recognize these is here's an example. So we have x squared plus 6x plus 9. So to see if this is a perfect square trinomial, we say, okay, well, this is a squared. So that means a has to be simply x, because if you take the square root of x squared, you get just plain x. Then this has to be b squared, according to my little format. And so that means b must just be a plain 3, because again, square root of 9 is equal to 3. And to check, we have to make sure that this actually is what it's supposed to be. So 2 times a times b should be 6x. So 2 times a, which is an x, times b, which is a 3, does in fact make 6x. So that means that this is a perfect square trinomial. So I can factor this very quickly to being the value of a, which is an x. Then, since this is a plus here, this is going to be a plus here. Then the value of b, which is a 3. And then close the parentheses and squared. So this factored form is simply x plus 3 squared. Let's try it again with another one. Now let's look at example 2. So let's see if example 2 is a perfect square trinomial. So 4x squared is a squared, so that means a has to be a 2x, because the square root of 4 is 2 and the square root of x squared is x. This 25 is actually b squared, so b should just be plain 5, because the square root of 25 is a 5. So now we have to check and make sure this is actually negative 2ab. And it's negative because this is negative, so I'm using this guy here. So negative 2ab should be what this is. And let's see. So negative 2 times a, which is 2x, times b, which is 5. Well, negative 2 times 2 is negative 4, times 5 is negative 20x. So yes, this is also a perfect square trinomial. So when you factor this, it's going to be a, which is 2x, minus, because that's what this is here, and then b, which is a 5, and then all squared on the outside. Factored very quickly because we recognize this as a perfect square trinomial. So take number 3. First, pause the video, check and see if it is a perfect square trinomial, and if it is, see what the factored form is. So yes, this one is also a perfect square trinomial. This is a squared, so that means a is actually 3x. Take the square root of it to find a. This is actually b squared, and if you take the square root of 1, you still end up with a 1. So b is also equal to a 1. Ones are always kind of weird. And then we check the middle term to make sure it's actually 2 times a times b. So 2 times a times b does in fact make 6x. So when you factor this out, you end up with the a value of 3x plus, because this one's a plus, the value of b, which is 1, squared. And then finally, the last one. These are some gigantic numbers. But again, to check it, it's not too bad. This should be a squared, so if I take the square root of that, I end up with 5x. This should be b squared, so that means b is actually 7. And this in the middle should be negative 2ab. So negative 2 times a times b. Well, this makes negative 10x times 7 makes negative 70x, which is what we have. So this is a perfect square trinomial. So factoring this is actually easy. We have a, 5x, minus b, which is 7, all squared. So recognizing a perfect square trinomial makes trying to factor things a lot simpler, because this would have been a very monstrosity job trying to solve with the a times b table and everything that way. Now that we know how to recognize a perfect square trinomial, let's talk about actually completing the square. So here's your general process. You can read this on your own. I'm just going to work through these steps over here with this example. So the reason why we have completing the square is we found out that not everything is factorable. And I can't solve this with square roots yet because I have 2x terms and I can't use 2x terms with square roots. So we first say, okay, well, I need the a value to be positive, but I also need the a value to be a 1 in order to complete the square. So what that means is I need to divide all of these by 6, and even the 0 has to be divided by 6. The reason I chose 6 is because I need a value to be 1, and if I do 6 divided by itself, I get a value of 1. Okay, so we end up with x squared. 12x divided by 6 makes 2x. 12 divided by 6 makes 2 equals 0 divided by 6 makes 0. Now, trying to factor this out, let's look. If we do a times c, so 1 times 2 is 2, but there are no numbers that multiply to 2 but also add up to 2, because 1 times 2 adds up to be a 3. So this doesn't factor, which is why we need something else in order to solve it. So we actually are going to use complete the square. So right now with complete the square, it hinges on having a perfect square trinomial. Well, if I look at this the way it is, B is not, or C is not a perfect square. I cannot take the square root of 2 and get something nice and pretty. So this is not a perfect square trinomial. So what we do is we're going to create a perfect square trinomial ourselves. So what that means is, that means this C value is not something that I can use. So I'm going to move the C value to the other side. X squared plus 2x equals negative 2. So what I've done is I have kicked out the C term that doesn't work. And I'm going to create a C term myself. And the way we do that is this step 4. We're going to take the value of b and divide it by 2. So over here on the side, I'm going to take b and divide it by 2. So here's b. So we're going to have 2 divided by 2, which makes 1. Now, in order to get a perfect square trinomial, my value of c must be a perfect square. So I'm going to create that perfect square. I'm going to take b over 2 and square it. So I'm going to take 1 and square it, which still ends up being a 1. So really, this is my new c. That's my new c value. So when we put this in here, x squared plus 2x plus 1 as my new c value, well, problem is I can't just add it to one side and not the other, so we're going to add the 1 to both sides. You can't just pop it in and call it a day. So whatever you do to the left, you have to do to the right. So what we've done is we've created our new value of c, added it to both left and right to keep the balance, and now what we've created is we've created this side to be a perfect square trinomial. A is a 1, or it's actually an x, b is a 1, and if you do 2 times x times 1, you get 2x here in the middle. So this factors very quickly into x plus 1. And this is positive, so this is positive, squared. Now the right side, negative 2 plus 1, well, that makes negative 1. Okay? Now look what happened also. This guy here, without squared, is actually ending up inside of here. These should be the same numbers every time. Okay? Now, this is something that we can solve. This is completing the square. You have completed the square. What we're going to do now is we're going to solve this out for x. So that requires me to take the square root of both sides. So we end up with x plus 1 equaling plus or minus the square root of negative 1. Now, remember that the square root of negative 1 is actually an I. That's your imaginary piece. So we're going to subtract 1 from both sides, and we end up with x equals negative 1 plus or minus I. And there would be the solution to this problem. A little bit quicker than factoring. Okay, let's do another one. So for example 2, we're going to solve this by completing the square. It needs to be in standard form, though, before I can do anything. So I need to multiply in 4x. So 4x times x makes 4x squared. 4x times negative 4 makes negative 16x equals 24. Now, I don't have to move my c value because if you notice, your c value is already over on the other side. So what I do need is I need this to be a 1. So we're going to have to take everything left and right and divide it by 4. So this becomes x squared minus 4x equals 6. Okay? Now create your new value of c. You're going to take b over 2. So we're going to get negative 4 divided by 2, which makes negative 2, But then we're going to take that b over 2 and square it to make my new value of c. So negative 2 squared is a positive 4. So again, this is the new c value. Add it to both left and right-hand sides. So x squared minus 4x plus 4 as my new c value equals 6, but then I also have to add plus 4 over here. Okay. What you've done is you've created this now to be a perfect square trinomial. So since this is a perfect square trinomial, I know that's going to be x minus b over 2, which is a negative 2. Well, x minus 2, I already have the negative part. X minus 2 squared equals 10. Now that you have completed the square, you can solve this by square rooting. So square root the left, square root the right. X minus 2 equals plus or minus square root of 10. Check and see if you can simplify. Square root of 10, you cannot be simplified because 10 is simply 5 and 2. But if you can simplify, then make sure you simplify the square root. So now continue solving for x. Add 2 to both sides, and you end up with x equals 2 plus or minus square root of 10. Definitely quicker than factoring. So for example 3, the area of a parallelogram can be determined by using the formula A equals BH, where B is the base and H is the height of the figure. If the area of the figure below is 48 square units, what is the value of x solved by completing the square? So I give you the formula, and I tell you that the area itself is 48. So I know that area is 48, and I'm looking for x. So if the area is 48, that means I have 48 is equal to the base, which is x plus 6, times the height, which is simply x. Now again, simplify this out. X times x makes x squared. X times 6 makes 6x equals 48. We do not need to move the value of c because the value of c is already on the other side. And we also don't have to divide by anything because a is already a 1. So this is pretty much set up for us to begin the completing the square process. So we need to create our new value of c. And we do that by taking b and dividing it by 2. So 6 divided by 2 makes 3. And then to finalize the value of c, we're going to take b over 2 and square it to get 3 squared, which equals 9. So this is the new c. So now we're going to have 48 plus 9, because remember you have to add it to both sides. You can't just add it to one, equals x squared plus 6x, and then add the 9 here as my value of c. So this is now the new perfect square trinomial. So this factors very quickly. We're going to have x plus, and then the square root of 9 is 3 squared, equals 48 plus 9 makes 57. Okay, we're going to solve this very quickly, but I'm going to actually move it up here to solve. I'm going to move it up here. So 57 equals x plus 3 squared. So to solve this out, take the square root of both sides. So we get x plus 3 equals positive or negative square root of 57. Square root of 57 is not something that can be simplified, so we're going to leave it the way it is. Okay, finish solving by subtracting 3. I'm going to put the x on the left. So x equals negative 3 plus or minus square root of 57. Now, normally we would say we're finished because this is the solution, but because this is real world, we need to evaluate the reasonableness of the answer. And so remember that this is really two pieces. This is really x equals negative 3 plus the square root of 57, and this is really x equals negative 3 minus the square root of 57. So let's think about this height here as just x. This is a positive height. Square root of 57 is larger than 3 more than likely, because 7 times 7 is 49. So this has to be at least 7 or 8. And so this will give us a positive number. This over here, though, gives us a negative number. Negative 3 minus something else is a larger negative number. So we have to reject this side as a solution. So really the only solution to this problem is x equals negative 3 plus the square root of 57. Not the negative or the minus side, because that creates a negative length, which is not possible. You can also use completing the square to change standard form into vertex form, okay? So I have some general steps on the left, which kind of looks crazy, but we're just gonna follow it on there. We're gonna actually do an example together. So use completing the square to convert the standard form quadratic function into its vertex form. So I have f of x equals x squared plus 12x plus 37. So first of all, let's change this f of x to make it simpler. So this is really just y equals x squared plus 12x plus 37. So remember, the key to completing the square is creating a value of c to make it be a perfect square trinomial. So that means I need to kick out the current value of c. So I need to move over that negative 37. So we're going to kick this guy out. So on the left, we have y minus 37, which we can't really do anything with, just leave him be, equals x squared plus 12x. Okay? Now we don't have to divide in this problem because a is already a 1, so we're okay there. Now to create the new value of c, so we're going to take b over 2, and we're going to basically square it if you want to simplify your process a little bit. B over 2 squared. So we're going to take 12 over 2 and square it. 12 over 2 makes 6, and 6 squared is 36. So this is the new value of c. So we have y minus 37 plus 36, because we're going to add it to both sides, not just one side, equals x squared plus 12x, and then now plus 36. So over here is the perfect square trinomial. So this simplifies down into x plus square root of 36 is 6 squared equals, and then I'm going to add these up. Negative 37 plus 36 makes negative 1. Well, this is almost vertex form. For vertex form, you need to add the 1 over, and you end up with y equals x plus 6 squared plus 1. There's the vertex form of this parabola. You have standard form, and now we have vertex form. And the reason we need to do this is sometimes we need to get this vertex very quickly, and you can't really get the vertex from standard form. But now that it's in vertex form, I know that this is h and this is k. So my vertex is very easy to find. It's negative 6, 1. That's why this is helpful. Sometimes the vertex is more meaningful than you have in standard form. So I want you to pause the video, try and get example 5 into its vertex form, and then identify the vertex. Go ahead and pause the video and try it out. Here's what you should have had. You should have had y equals x minus 4 squared minus 7 as the vertex form, and the vertex is a positive 4, negative 7. Remember, it's always the opposite sign here. Now let's look at example 6. What happens if it's not quite as simple? So convert into vertex form. Well, I have an a value that is not a 1. So now I'm going to actually have to divide by something. So let's do that first. So I'm going to divide everything by the value of a, including the y on the left-hand side. So y divided by 3 is simply y over 3. You can't do anything with that. So equals 3x squared divided by 3 makes x squared. Negative 36x divided by 3 makes negative 12x. And negative 9 divided by 3 makes negative 3. Now I have the a value as a 1, but I need to get rid of the current value of c. So I have to add over the 3 to the other side. And I can't do anything with y over 3 plus 3. So I'm just going to leave it as y over 3 plus 3 equals x squared minus 12x. Now that I have everything moved, we need to create a new value of c in order to factor this easily. So I'm going to take b over 2 and square it to create my new value of c. So negative 12 over 2 and square it, which makes negative 6 squared, which will make a positive 36 as my new value of c. So now we have y over 3 plus 36, because you have to add it to both left and right. You can't just add it to one side, equals x squared minus 12x plus 36 on the right, which this makes my perfect square trinomial here. So we end up with y over 3. I can add these two together to make 39. I can at least do that. And then I can factor this very quickly because it is a perfect square trinomial. That's what I've created. And so we end up with x minus, then the square root of 36 is 6 squared. Now, to get this into vertex form, we're almost there. So I'm going to move over the 39 back to the other side. So we have y over 3 equals x minus 6 squared minus 39. Now, I have to get rid of this this division by 3 by multiplying by 3 to the left, and I have to multiply 3 to the right. But I multiply everything, not just the 39. So your final vertex form is y equals 3 times this x minus 6 squared is just 3 parentheses x minus 6 squared. And then 3 times negative 39 is negative 117. So this is the final vertex form. So when you have a division here on y, when you multiply it across, you need to multiply everything. So that includes this parenthesis, and it includes this value on the right-hand side. Finally, the vertex is the same as it always has been. 6, negative 117 would be the vertex.